Without the moon, most of the coastal life as we know, it will exist. Tide out, tide in, we see that every day. But how you ever stop to think about the invisible tether that connects our oceans to a rock 380,000 kilometers away? And that rock controls when the animals eat, reproduce, and even migrate. Tides are more than just water moving forward and back. They are the poles of our planet. They dictate where the animals can live and even set the clocks for one of the most spectacular migrations on Earth. Today, in ocean science, we are diving into the physics of Newton, the spherical cow of oceanography, and why the moon is the ultimate conductor of the orchestra. Before seeing why the water moves, we need to see where the water moves. The marine biologists divide the coastal zone in intertidal zones, based in how much time they spend underwater. We can start from up to the sprite zone, so the ones who only arrive the sprites of the wave. When they crash with the coast, the sprites arrives here and we don't find a lot of marine life. Then we have the high intertidal, so this part is only underwater in the high tides, so also we don't have a lot of marine organisms, but we have the ones who can survive without a lot of water. Then we have the middle intertidal. Here there is a lot of chaos because this place is covered twice a day, and here we have a lot of organisms as the sea stars or even anemones. So here we can have a lot of interaction of the organisms that needs the water to live, and they are fighting for the place. And finally we can have the low intertidal. Here is almost all day that they cover on the water, so the marine biodiversity explodes. Here we have the maximum point because the water helps to cover from the rate of sun, and they are completely covered by water, so they can live the life with nutrients and interactions underwater. So when the moon pulls the tide, the boundaries change and everyone needs to wait. So take a good breath and wait until the next one, but none of them happens by chance. It's pure physics. So to understand the how, we need to go back to Sir Isaac Newton and his laws. Specifically, we need to use the law of the universal gravitation. So I'll put this here. I hope it's working, and take this. So we can start saying that the force that we feel from the moon is this gravitational constant for the mass of Earth, for the mass of the moon, divided by the square of the distance that these two bodies has. So now I'm going to try to explain why it's called the spherical cow and what is this and how we can arrive to this in an easy way. So maybe it's not exactly accurate, so sorry if I make some mistakes in the specific way of saying in acceleration and force, but I will try my best. So here we have the force and say that I think I said before. So here we are consider the two masses, so Earth and the Moon here, as the center point. So the force that we have from one point to the other, from one center of mass to the other. No? But the truth is that the tidal force, it will be this force. So the difference between the surface and the center, because when we are considered the tides, we're considered the ocean that is here. So if we surround the whole sphere here, we can consider the difference between this point and this point. And why it is called the spherical cow? Maybe you're seeing now the Earth is not like this. The ocean is not the whole Earth, and we have also continents, and the moon is also not completely spherical. So the thing is that we are trying to calculate how a cow is formed or how the cow weighs. So this is because it's called the spherical cow. It's the way that we have to compare things and like do maths with it, but knowing that it's not real. We are talking about the Earth, but the Earth is not completely round. The Earth has continents, and here we don't have have continents, and the ocean is not in the whole Earth covering everything. So we cannot compare one point to another, taking into consideration that every point it will be equal to each other. But is the easiest way, is the way the Newtons calculate everything and helps to arrive to the meaning of the tides. So works, and that is the problem, that works. But that is why the physics works in like an imaginary place. So the illusion of everything without friction and the spherical perfection. The reality is not like that, but it's similar to it, so we will keep it. And here we have this difference. So the tidal force, it will be this. So the difference between the force. So it's this. If we put the calculation here and we do all the maths that we need, we will arrive to something like this. That is similar to, is not equal. Also, we are doing a lot of simplifications of binomials, binomials, yeah, I think is the name. And here we arrive to the tidal force that we will have from the moon. And the trick here is this. So here we will not have the square of the distance, we will have the cube of the distance. So why is this important? Because even if we have the sun that, yeah, we can put it here, for example, and in a scale that I have invented right now, it can be something like this. And so you see that the mass of the sun, so the mass number 3, maybe this is mass number 2 and this is mass number 1. If we switch the mass number 2 from the mass number 3, so if we calculate the force of the sun, you think, okay, it's bigger because the mass here is, yeah, the difference is crazy huge. But we have more distance between these points. And as we are talking about the cube of the distance here take a main role. So it's more important than the mass that the object has. So for that is one of the main reasons that we will have the tides guided by the moon, so not by the sun. And this is important to understand why the maths are useful to understand this, even if it's a spherical earth or a spherical cow. So now I can take this. I saw the clip. I hope that was useful to understand something. I see that I need to cut my hair. It was not maybe the best clip ever, but I try my best. I hope that you understand and I didn't make any physical mistake. I hope so. If I saw it in the edition, I will put it down, but I think it's do it well. So after all this, of course, we have a lot of celestial bodies in our small part of universe, but not all of them has enough mass or are near to have any effect on our tides. You can calculate by yourself with the gravitational constant and put the different mass of the different planets that we have, and you can calculate how much force we will have from that. And then of course we have more maths to do. You can add deceleration that is more technical to see the acceleration of the tides and how they rotate, and you can have more accurate models that takes in consideration the continents or the ocean's mass, and yeah, we can do more maths as you want, but the main concepts are these ones. So with that, we can see that the sun, sometimes if it's in the same line as the moon, will have these huge tides. And this is a particular effect that we can have from tides with the sun in the same line or in the opposite line. But the main effect that we will have in the tides comes from the moon. And of course, the spherical cow has some problems. If we consider the Earth as a sphere, a perfect sphere, and the ocean as complete full water body that covers everything, we can have some problems calculate everything, because sometimes the reality change a little bit, and we can have examples as the last December of 24 with Peru having a normal tides in this time of the year. Here we had a lot of shallow waters, and this change in the fisheries and in everything because it was too low, and the change on the coast was huge. And this was an event that was unpredictable. So we still working in different models to understand better these tides anomaly. And the tides also change with the moon, and the moon change in stage because this can be near to the earth, a little bit forward, and we have the different stage of the moon. And when we have the full moon, that means that the moon is reflecting the whole light from the sun, and this creates a specific situation that we have light in the middle of the night, and this creates one of the biggest migrations on Earth. The vertical migration formed by the whole phytoplankton that we have in our oceans is the movement from the bottom to the surface, and this is one of the huge movements that we have on Earth in mass consideration, because even if these organisms are tiny, we have this movement of thousands and millions of them. So in biomass compare is the biggest one that we have on Earth. And this movement of course comes with the movement of the fish that finds this, the sharks that find the fish, so the entire food web starts to work. We have also the corals, for example, that starts the reproduction with the full moon light, because they have a protein, the L-cryptochrome, that is not a crypto, it's a protein that this organism has to take this light and take it as the start of the reproduction cycle. But for the first time in history, we are overpowering the moon. We are breaking the moon's connection with Alan. Alan is not the guy that is breaking the connections with the moon in the earth. It is the artificial light at night. This is the phenomena that we are having in the coastal zones and even in the middle of the ocean with the different fisheries or the boats and ships that are there, because the artificial light means for the animals that didn't evolve to see light that they have full moon. So this changed everything. So we can see that the phytoplankton get confused. Before in the past, the fisheries use these candles to put some light, and most of this phytoplankton starts to come to the light and then the fishes, so they can fish on the night, and this can be useful to a small village in the past. Nowadays there are big fisheries, there are a lot of ships in the ocean, all the coastal zone is full of lights, so this is changing the behavior of the animals that lives there and works with the natural cycles of light, so light in day and without light in the night. And if something happens on the night to have the light, it will be a particular situation with the full moon. But this is not true anymore, and we are switching everything, and it will be a problem for the behavior of the animals and the environment here. So that is how the moon interacts with the earth from tides until light, and how everything is changing now with the light and what we can expect from the tides. So this was an interesting video to make because I want to put together two concepts that for me were related with the moon. So I think that the lights that we are not seeing natural anymore is interesting to know, but it's also interesting to know that it's related with the tides and how. So it's a little bit mixing different things and maybe topics that are not completely correlated, but it's a good way to understand how everything is correlated in some way. And I hope that you like this video, you find interesting and you learn something here. And if you like, you can share with more people, and I will see you in the next video. Bye bye.